Hello. All right. Hello, everybody. Today we're presenting the AIS Data Archiver. This is a project sponsored by Newick. Our client is Stephen Grudman, and my name is Don Gouet. I'm the team lead. Allison Poe is our Scrum Master and developer, and Alicia Soriano, Alex Woodland, and Michael White are all developers. So to begin, let me explain what AIS data is. So AIS stands for Automatic Identification System. It's a collision avoidance tool used by ships on the water. An AIS-equipped ship will provide information about its current position, speed, course, and other ship and voyage-related information. Now, AIS data is constantly being transmitted to other AIS-equipped ships and stations on the shore within a certain range. This is important because it allows for a ship to view the current positions and behaviors of nearby ships. And not only do ships transmit their own AIS data, but they also forward nearby ships' AIS data, creating this local network of AIS data among ships. So these shore stations work similar to these AIS-equipped ships, where they receive data and they forward that data. But it also allows for entities on land to view and monitor AIS traffic in the local area. Now, in today's world, information is constantly being shared thanks to the internet, and this is no different with AIS data. Most AIS short stations will provide a feed of AIS data to some web source, and these web sources provide open AIS data to the public. Our application gathers data from these different web servers and implements it into our own centralized database for the application. Now, to collect our data, we use the JSoup API, which is an HTML parsing library for Java. Using this API, we're able to implement web scraping and web crawling methods. And to briefly describe how this works, a web crawler will first connect to a web source to access its HTML code. At that point, it'll search for the table of ships, which you can see on the slides up there, and it'll pass each individual link for each ship to our web scraper, and that's where our web scraper will access each page for each ship and extract its AIS data and store it in our database. Now, this stored AIS data can be viewed through our application's graphical user interface. This information can be represented through tables, charts, and geographically through Google Maps. A user may also exclude ships from the recording process or make modifications to existing data. So to take a look at how our application works, it's made up of three main components: the user interface, the web scraper, and the database server. And each of these components run independent from each other and follow a client-server model. So as I mentioned, the web scraper is a continuous process that just accesses web pages, reads the data, and stores it in our database. But our user interface provides tools for the user to view and make modifications to the data. Now, the user interface makes some requests to the database server. The database server will then return the results back to the user interface and to be viewed how the user had specified. So now let's take a look at the AIS Data Archiver in action, and we're going to start with the web scraper. So as you can see here, we have our web scraper. Now, this is actually a background process. You don't actually see this, but for today's purposes, we actually put together a little demonstration to help visualize the process. So you might notice that the web scraper is running a little bit slow, and that's because we have to comply with the web server's rules on the speed at which we can access their content. In this case, our threads are running every 5 seconds. So, mentioning threads, we have 2 threads here, and that's accessing 2 different web sources. So if we actually stop this, we pause this, we can actually take a look at the data. I know it's probably hard to see, but we can access one of our web sources that we grab the data from, and we can see that the data will match. So while she's doing that, like I mentioned, this is a background process. So nobody actually sees this. It'll either, you can either have it run on the background, or you can have it run on multiple machines as well. So yes, it looks like the data matches up as it should. So now we can close this. And now we can show you how we use this AIS data.
All right, we're gonna launch the application for you guys. When the application launches, we have a preloader. It's gonna allow the program to connect to the database as well as allow the GUI to gather data. As you can see, this is the main page of our application. In the top menu bar, we also have edit, report, and help pages that you can see, which I will get to shortly. So this is the ship locator page. The purpose of the ship locator page is to be able to geographically see the position as well as the path taken by a particular ship. When you first launch the application, the map on the right-hand side is a heat map. It shows the most populated areas of the world with AIS traffic. On the bottom left-hand side, there's a table that shows the most recently added entries into the database. With this table, we're able to load more entries, meaning we can load the next 100 entries from our database, as well as refresh the table. So this is so that if the user's been working with the application for a while, they're able to gather the data entries that were gathered from the scraper while they were working with the application. Now, how the ship locator page works is you're able to search for a ship in 2 ways. Either by its unique MIMSI number, which is a 9-digit number that kind of serves as a ship's ID, or by parameters. So with this particular page, our parameters are locate, flag, and speed. So let's say, for example, you're interested in seeing a ship that is from Canada and currently located in the north. We can go ahead and input those parameters, and when we click search, the table below will update with data entries matching those parameters. Now let's say you're aware of a particular ship that you want to find. In the top text field, you can input the 9-digit MIMSI number, and once again, when you click search, the table will update with entries of that one ship. Now if you double click on an entry, the map to the right will also update to show the path. So with this ship, it's called the KRK from Croatia. It shows the first entry in our database, as well as the most recently added one, and the path is connected so you can visually see. So now, as a user, you've been working on this all day, but you have to leave. You want to be able to use this information tomorrow. We allow the user to save this information. So we'll go ahead and exit out of the program, and now a prompt appears asking whether we want to save the current state. We'll go ahead and select yes. Now we're going to relaunch the application. The preloader will be gathering the information that we just saved, and once again, we're going to be prompted with whether we want to load this save state. And we just ask this again, just in case that in the future you actually do want to start from scratch, you can do so by selecting no. But here we'll select yes. And as you can see, the information has been saved. After this, we're going to head over to our next page, the edit page. There it is. So this is the data editor page. The purpose of the data editor page is to be able to see more information for each data entry, as well as to edit the data. So the ship we were just working with, the KRK from Croatia, has been updated onto this page. However, we can see information like its length and width, as well as its last report date and time. This page works very similar to the ship locator page, where we can search for a ship either by its 9-digit MIMSI number or by parameters. However, we're able to search by more parameters. So let's say, for example, we're interested in seeing ships with a last recorded date of today's date. We can head over to last report date and just select today's date. And then when we click search, the table will update with entries of today's date. Now we'll show you how we can actually edit this data. We'll head over to the Edit Data button, and a new window appears, offering 3 options: add, edit, and delete. So add, meaning you add a new entry into our database. So say as a user you are aware of more information that the web sources do not provide, you can simply add it. Then we have the edit page. Likewise, if you know more information, such as maybe its length and width weren't grabbed from the web scraper, you can once again input that. And then we simply can delete an existing entry. So we'll walk you guys through all 3 steps. First, we'll add a ship. Just for the purpose of today, we'll call it demo ship. With this, you have to have the ship's 9-digit MIMSI number, the latitude and longitude so that we're able to plot it on the map, as well as a last report date and time. From here, we can go ahead and save this and confirm that we want to save it. And now we'll just search for this ship to show you that it has been added into our database. And there it is in the top. So now we'll select this ship and head back over to Edit Data. We'll select that middle option, Edit, and now say we're aware that the destination is China. We can just simply type it into the text field, save and confirm this, and now when we refresh this table, we can see that those changes have been updated. And lastly, we can simply select it, head back over to Edit, and then just delete this. So that's how we can delete a single entry in our database. But what if you don't want any entries for a particular ship? We allow the option to exclude ships. So we will head over to the Exclude Ships button, and now we are brought to this page. So we can simply add a MIMSI number in the top text field. And now when a MIMSI number is added, the table in our database will get this MIMSI number. The web scrapers communicate with this table, and now they are aware to no longer grab any entries for that particular ship. But then, say in the future you do decide you want entries for the ship, you can just as easily select it and delete it from this list. So that finishes up the data editor. Now we'll head over to our report page. So this is a collision report page. It's an additional feature to our project. As it stands, AIS Data is used as a collision avoidance tool. But with this additional feature, there's potential for it to become a collision detection tool. So how this page works is you are able to input 2 specific MIMSI numbers. The right-hand side is divided into 3 main components. There's a 30-day speed comparison chart. It plots the average speed for each day, for each ship. The information box to the right of it serves as a key, so that we know that the red ship belongs to the red lines of the page, as well as the blue ship to the blue lines. And just below that, there's a map that plots the paths taken by each ship. So using all this information, we can look at the speed comparison chart and see that neither ship has been moving recently. In fact, the most recent movement, which was very slightly, was April 13th. Now looking below, we can see that although these ships are in the same general region, they're not actually close enough where their paths are going to look like they're going to touch. So using all this information, we can safely say that these 2 ships are not at risk of a collision anytime soon. So we'll just head over to our last page, the help page. This page gives general information about how to use this application, as well as understanding the application. It's broken down into these 6 main components, all of which work in the same manner. So we'll just go ahead and select the first one, locate ships. We are presented with a couple headers, and if we select a header, more information below will appear. So we have search by MIMSI, search by parameters, but we also have in our last header something called how to understand the map. And we felt we needed to add this to our application just to explain that the sources we are grabbing data from may not provide information at every split second. So paths on the map may seem choppy. They may seem to be crossing over corners of land, and that's simply because the data we are gathering is not consistent. So we can exit out of that, and now that concludes our demo portion. I'm going to talk a little bit about our software process. So we followed agile methodologies. Specifically, in the beginning, we worked with extreme programming to really get down the main components of our application. But for the full duration, we worked with Scrum. And for all of our project management needs, we use the web-based application Trello. When it comes to actually developing our application, we use Eclipse for all of our programming. We use JavaFX for the GUI, JDBC for database connectivity, JSoup for web scraping, and the Google Maps API for our geographical representations. And all of our source and version control was used Bitbucket and Git. So that concludes our presentation. We are open for questions.